Meow? Hello, it's me, Dia. You wanna learn about glass? Let's go. Glass is a non-crystalline solid that is often transparent. Often means it's not always transparent. Brittle and chemically inert. It has widespread practical, technological and decorative use. For example, window panes, tableware and optics. Glass is often formed by rapid cooling, quenching of the molten form. Some glasses, such as volcanic glass, are naturally occurring. The most familiar and historically the oldest types of manufactured glass are silicon glasses, based on the chemical compound silica, silicon dioxide or quartz, the primary constituent of sand. Oh, it's not a different sentence. Oops. Soda lime glass containing around 70% silica accounts for around 90% of manufactured glass. The term glass in popular usage is often used to refer only to this type of material, although silica-free glasses often have desirable properties for applications in modern communications technology. Some objects, such as drinking glasses and eyeglasses, I'm wearing some right now, are so commonly made of silicon-based glass that they are simply called by the name of the material. Oh, hello, cat. Despite being brittle, buried silicon glass will survive for very long periods if not disturbed, and many examples of glass fragments exist from early glass-making cultures. Archaeological evidence suggests glass-making dates back to at least 3600 BC in Mesopotamia. Oh, that's a long time ago. Egypt or Syria. The earliest known glass objects were beads, perhaps created accidentally during metalworking or the production of faience. What's that? General English language term for tin glazed pottery. The invention of white pottery glaze suitable for paint and decoration. La la la. Due to its ease of formability into any shape, glass has been traditionally used for vessels, such as bowls, vases, bottles, jars, and drinking glasses. In its most solid forms, it has also been used for paperweights and marbles. Marbles. Glass can be colored by adding metal salts or painted and printed with vitreous enamels. I'm not gonna read that. Leading to its use in stained glass windows and other glass art objects. The refractive, reflective, and transmission properties of glass make glass suitable for manufacturing optical lenses, prisms, and optoelectronics materials. Extruded glass fibers have application as optical fibers in communications networks, thermal insulating material when matted as glass wool so as to trap air, or in glass fiber reinforced plastic. Fiberglass. Microscopic structure. The standard definition of a glass or vitreous solid is a non-crystalline solid formed by rapid melt quenching. I'm not gonna read that. However, the term glass is often defined in a broader sense to describe any non-crystalline amorphous solid that exhibits a glass transition when heated towards the liquid state. Glass is an amorphous solid, although the atomic scale structure of glass shares characteristics of The characteristics of the structure of a supercooled liquid. Glass exhibits all the mechanical properties of a solid. As in other amorphous solids, the atomic structure of a glass lacks the long-range periodicity observed in crystalline solids. Due to chemical bonding constraints, glasses do possess a high degree of short-range order with respect to local atomic polyhedra. The notion that glass flows to an appreciable extent over extended periods of time sorry. The notion that glass flows to an appreciable extent over extended periods of time well below the glass transition temperature is not supported by empirical research or theoretical analysis. See viscosity in solids. The atomic motion on glass surfaces can be observed, and the viscosity on the order of 10 by the power of 17 to 10 by the power of 18 pascals can be measured in glass. Wait. Is it pascals or... I don't know. Such a high value reinforces the fact that glass would not change shape appreciably over even large periods of time. Unsolved problems in physics? What is the nature of the transition between a fluid or regular solid and a glassy phase? The deepest and most interesting unsolved problem in solid-state theory is probably the theory of the nature of glass and the glass transition. Phoenix Wright Anderson. Formation from a supercooled liquid. For melt quenching, if the cooling is sufficiently rapid relative to the characteristic crystallization time, then crystallization is prevented, and instead the disordered atomic configuration of the supercooled liquid is frozen into the solid state at Tg. I have no idea what that means. What are? The tendency for a material to form a glass while quenched is called glass forming ability. This ability can be predicted by the rigidity theory. Generally, a glass exists in structurally metastable state with respect to its crystalline form, although in certain circumstances, for example in atactic polymers, there is no crystalline analog of the amorphous phase. This isn't very fun fact, this is just science. Glass is sometimes considered to be a liquid due to its lack of a first-order phase transition, where certain thermodynamic variables such as volume, entropy, and enthalpy are discontinuous through the glass transition range. In thermodynamics, enthalpy is the sum of a thermodynamic system's internal energy and the product of its pressure and volume. It is a state function used in many measurements in chemical, biological, and physical systems. I still don't understand it. The glass transition may be described as analogous to a second-order phase transition, where the intensive thermodynamic variables such as the thermal expansivity and heat capacity are discontinuous. However, the equilibrium theory of phase transformation does not hold for glass, and and hence the glass transition cannot be classed as one of the classical equilibrium phase transformations in solids. Occurrence in nature. Glass can form naturally from volcanic magma. Obsidian is a common volcanic glass with high silica content formed when felsic lava extruded from a volcano. When felsic lava extruded from a volcano cools rapidly. Impactite is a form of glass formed by the impact of a meteorite, where moldavite, found in Central and Eastern Europe, and the Libyan desert glass, found in areas in the Eastern Sahara, the deserts of Eastern Libya and Western Egypt, are notable examples. Water. Vitrification of glass can also occur when lightning strikes sand, forming hollow, branching, root-like structures called fulgurites. Trinitite is a glassy residue formed from the desert floor sand, the Trinity nuclear bomb test site. Oh, they made new glass by creating a bomb. Adobe glass found in South Australia is proposed to originate from Pleistocene grassland fires, lightning strikes, or hypervelocity impact by one or several asteroids or comets. Another thing. Nuclear glass. Meow. History. Naturally occurring obsidian glass was used by Stone Age societies, as it fractures along very sharp edges, making it ideal for cutting tools and weapons. Glass making dates back to at least 6,000 years, long before humans had discovered how to smelt iron. See, glass did it first. So I already read that. Archaeological evidence suggests that the first true synthetic glass was made in Lebanon and the coastal North Syria, Mesopotamia, or ancient Egypt. The earliest known glass objects of the mid-3rd millennium BC were beans, perhaps initially created as accidental byproducts of metalworking, slags, or during the production of faience, a pre-glass vitreous material made by a process similar to glazing. Early glass was rarely transparent and often contained impurities and imperfections, and is technically faience rather than true glass, which did not appear until the 15th century BC. That's still pretty long ago. However, red-orange glass beads excavated from the Indus Valley civilization dated before 1700 BC, possibly as early as 1900 BC, predate sustained glass production, which appeared around 1600 BC in Mesopotamia, and 1500 BC in Egypt. That's a lot of numbers and I'm not keeping up. During the late Bronze Age, there was a rapid growth in glass-making technology in Egypt and Western Asia. Archaeological finds from this period include colored glass ingots, vessels, and beads. Much early glass production relied on grinding techniques borrowed from stoneworking, such as grinding and carving glass in a cold state. term glass developed in the late Roman Empire. It was in the Roman glassmaking center Trier. Trier, located in current-day Germany. Maybe it's Trier or something like that. Then the late Latin term glisium originated, probably from Germanic word for a transparent lustrous substance. Glass objects have been recovered across the Roman Empire in domestic, funerary, and industrial contexts, as well as trade items in marketplaces in distant provinces. Examples of Roman glass have been found outside of the former Roman Empire in China. What? Oh, so the glass traveled from the Roman Empire to China, okay, the Baltics, the Middle East, and India. The Romans perfected cameo glass produced by etching and carving through fused layers of different colors to produce a design in relief on the glass object. Wow. Water is good. Stay hydrated. Actually, go drink a glass of water right now. In post-classical West Africa, Benin was a manufacturer of glass and glass beads. Glass was used exclusively in Europe during the Middle Ages. Anglo-Saxon glass has been found across England during archaeological excavations of both settlement and cemetery sites. From the 10th century onwards, glass was employed in stained glass windows of churches and cathedrals, with famous examples at Chartres Cathedral and the Basilica of Saint Denis. By the 14th century, architects were designing buildings with walls of stained glass, such as Sainte-Chapelle, Paris, 1203 to 1248. In the east end of Gloucester Cathedral, with the change in architectural style during the Renaissance period in Europe, the use of large stained glass windows became much less prevalent, although stained glass had a major revival with Gothic revival architecture in the 19th century. Blah. My throat is not used to talking so much. Windows in the choir of the Basilica of Saint Denis, one of the earliest uses of extensive areas of glass. Big windows. During the 13th century, the island of Murano, Venice, became a center for glassmaking, building on medieval techniques to produce colorful ornamental pieces in large quantities. Murano glass makers developed the exceptionally clear colorless glass Cristallo, so called for its resemblance to natural crystal, which was extensively used for windows, mirrors, ship's lanterns, and lenses. In the 13th, 14th, and 15th centuries, enameling and gilding on glass vessels was perfected in Egypt and enameling and gilding on glass vessels was perfected in Egypt and enameling and gilding on glass vessels was perfected in Egypt and Egypt and Egypt and Syria Egypt and Syria. Enameling and gilding of glass vessels was perfected in Egypt. Enameling Why can't I say Why can't I say it? Enameling and gilding on glass vessels was perfected in Egypt and Syria. There. Towards the end of the 17th century, Bohemia became an important region for glass production, remaining so until the start of the 20th century. We've almost caught up to the real time. By the 17th century, glass of the Venetian tradition was also being produced in England. In about 1675, George Ravenscroft invented lead crystal glass, with cut glass becoming fashionable in the 18th century. Ornamental glass objects became an important art medium during the Art Nouveau period in the late 19th century. Water. I need water. Throughout the 20th century, new mass production techniques led to widespread availability of glass in much larger amounts, making it practical as a building material and enabling new applications of glass. In the 1920s, a mold etch process was developed, in which art was etched directly into the mold, so that each cast piece emerged from the mold with the image already on the surface of the glass. Wah! This reduced manufacturing costs, and combined with a wider use of colored glass, led to cheap glassware in the 1930s, which later became known as depression glass. Tell me about it. In the 1950s, Pilkington Bros, England, developed the float glass process, producing high-quality distortion-free flat sheets of glass by floating on molten tin. Modern multi-story buildings are frequently constructed with curtain walls, made almost entirely of glass. Milk, excuse me. Laminating glass has been widely applied to vehicles and windscreens. Optical glass for spectacles has been used in the Middle Ages. The production of lenses has become increasingly proficient, aiding astronomers as well as having other applications in medicine and science. Glass is also deployed as the aperture cover in many solar energy collectors. In the 21st century, glass manufacturers have developed different brands of chemically strengthened glass for widespread application in touchscreens for smartphones, tablet computers, and many other types of information appliances. These include Gorilla Glass, developed and manufactured by Corning, AGC Incorporated's Dragon Trail, and Shot AG's Sensation. What do you mean Gorilla Glass? In a nutshell, physical properties. It's transparent. Types. Ceramic cooktop. Oh wait, could you even see this picture before? There. Ceramic cooktop. I wonder if the lead glass is toxic, so let's read about that. The addition of lead 2 oxide into silicon glass lowers melting point and viscosity of the melt. The high density of lead glass silica plus lead oxide Pb0 plus potassium oxide K2O plus soda natrium 2O plus zinc oxide zinc-O plus alumina results in a high electron density and hence high refractive index, making the look of glassware more brilliant and causing noticeably more specular reflection and increased optical dispersion. Lead glass has a high elasticity, making the glassware more workable and giving rise to a clear ring sound when struck, like ting. This isn't lead glass, this is just my cup. Ting. However, lead glass cannot withstand high temperatures well. Lead oxide also facilitates solubility of other metal oxides and is used in colored glass. The viscosity decrease of lead glass melt is very significant, roughly 100 times in comparison with soda glass. Soda glass? Is that drinkable? This allows easier removal of bubbles and working at lower temperatures, hence its frequent use as an additive in vitreous enamels and glass soldiers. Oh, solders, not soldiers. The high ionic radius of the Pb2 plus ion renders it highly immobile and hinders the movement of other ions. Lead glasses therefore have high electrical resistance, about 2 orders of magnitude higher than soda lime glass. A bunch of numbers. Oh hey, I know what this is. I see the RW. I don't know what RW means. Chalcogenide glass forms the basis of rewritable CD and DVD solid-state memory technology. Interesting. Compact discs were made of glass apparently. Amorphous metals? What does this have to do with glass? Polymers. Production. Honestly, I'm tired. Maybe I'll come back to this later. Bye! Actually, let's look at the outro first. These are nice people. Meow.